Dear children, welcome to 10th Standard Physics.
Chapter 3 Electronics. In the previous capsule, we have studied Introduction to Electronics, Semiconductors and Types of Semiconductors. Capsule 2. In this capsule, we are going to study diodes and transistors. Children, let us recall that extrinsic semiconductor is a doped semiconductor whose conductivity can be increased or decreased. The types of extrinsic semiconductors are N-type and P-type. N-type semiconductor is obtained by adding pentavalent impurity in which the majority charge carriers are electrons. P-type semiconductor is obtained by adding trivalent impurity in which the majority charge carriers are holes. Extrinsic semiconductors are put into practical use by making semiconductor devices. They are diodes and transistors. To understand how these semiconductor devices are made, we must know about PN junction. Junction diode or semiconductor diode. Consider a semiconductor. An acceptor impurity is added to one side. Then that side becomes P-type semiconductor in which the majority charge carriers are holes and minority charge carriers are electrons. A donor impurity is added to the other. This makes it N-type semiconductor in which majority charge carriers are electrons and minority charge carriers are holes. At this time, the charges in the two semiconductors diffuse across the junction. That is, there will be movement of charges. When there is equilibrium, there is no further movement of charges. Thus, a potential difference is established. The junction stops further flow of charges. This device is called a junction diode or semiconductor diode. Junction diode. When a donor impurity is added to one side and an acceptor impurity is added to the other side of a pure semiconductor, a PN junction is formed. This is called junction diode. Children, note down this definition in your notebooks. Junction potential. The potential difference created in the PN junction due to diffusion of charges is called junction potential. The junction potential for silicon is 0.7 volt and that of germanium is 0.3 volt. Children, note down this important definition in your notebooks. Now it is time to pair up and answer. What is a semiconductor diode? Answer. When a donor impurity is added to one side and an acceptor impurity is added to the other side of a pure semiconductor, a PN junction is formed. This is called a junction diode. forward biasing. When a PN junction is connected to an external source of EMF, that is, a battery, then it is said to be biased. Now let us understand what is forward biasing. When P side of a PN junction is connected to positive terminal of a battery and N side of a PN junction is connected to negative side of the battery, then it is said to be forward biased. The external voltage overcomes the junction potential and provides an easy path for the flow of charges across the junction. The flow of electrons from N to P and of holes from P to N constitutes a forward current of milliamps from P to N. Current flows in one direction. This device offers low resistance. Let us move on to reverse biasing. Reverse biased diode. When positive terminal of a cell is connected to N side and the negative terminal to the P side of the PN junction, then it is said to be reverse biased. The charge carriers are repelled away from the junction and no current flows through the junction. Thus, it acts as a resistor. The device offers high resistance. However, there will be a small current due to minority charge carriers, that is, electrons in P-type and holes in N-type. Forward biased diode. When P side of PN junction is connected to positive terminal of a battery and N side of PN junction is connected to the negative side of a battery, then it is said to be forward biased. Children, write down this important point in your notebooks. Reverse biased diode. When positive terminal of a cell is connected to N side and the negative terminal to the P side of the PN junction, then it is said to be reverse biased. Children, note down this important point in your notebooks. Now children, from this we can understand that PN junction allows current in one direction only. Such a device is called diode. Diode acts as a conductor when it is forward biased and acts as a resistor when it is reverse biased. Now it is time for testing. Answer these questions. Children, think and answer. When does a diode act as a conductor? Answer. Diode acts as a conductor when it is forward biased. Note: PN junction allows current to flow preferentially in one direction only. This action is called rectifying action and the device is called rectifier. Children, note down this important point in your notebooks. Applications of diodes. Alternating current changes its direction once in every half rotation. To get flow of current in one direction, diode is used. Thus we can get DC current. And diodes are used in voltage regulation systems. Children, write down this important point in your notebooks. Symbolic representation of diode. Conventional current flows from P side to N side. Children, write down this important point in your notebooks. Children, now it is time to pair up and answer. Match the following. Side A. 1. Diode. 2. Forward biased diode. 3. Reverse biased diode. Side B. 1. Conductor. 2. Resistor. 3. PN junction. Answer. 1. Diode is a PN junction. 2. Forward biased diode acts as a conductor. 3. Reverse biased diode acts as a resistor. Now it is time to think and answer. Rectification is a process of option 1. Changing value of alternating current. Option 2. Changing value of direct current. Option 3. Conversion of AC to DC. Option 4. Conversion of DC to AC. Answer. The correct answer is option 3. Conversion of AC to DC. Children, now let us move on to another application of extrinsic semiconductors, that is, a transistor. Transistor. Transistor is a 3-terminal semiconductor device. The name is a shortened form for transfer resistor. Children, note down this important definition in your notebooks. Types of transistors: NPN transistor and PNP transistor. NPN transistor. It consists of one P region sandwiched between two N-type regions. As there are two N regions in this type, most of the current is constituted by electrons. PNP transistor. PNP transistor consists of one N region sandwiched between two P regions. As there are two P regions in this type, most of the current is constituted by holes. Now let us understand the different regions of transistors. Regions of the transistor. The middle region in both types of transistors is known as the base. It is lightly doped. It is a thin layer. The other two regions are emitter and collector. Emitter is more doped than the collector region. The function of the emitter is to emit electrons or holes depending on the type of transistor into the base. The base controls the flow of charge carriers into the collector. Collector collects electrons or holes depending on the type of transistor from the base. The emitter-base junction is forward biased and the collector-base junction is reverse biased. This controls the reverse flow of current from collector to base. Let us understand how these can be symbolically represented in a circuit diagram. Symbolic representation of transistors. Observe the symbolic representation of both NPN transistor and PNP transistor. Children, even though the symbols of both appear to be the same, it is very important to show the correct direction of flow of current. The arrow is showing the direction of conventional flow of current from P to N. Children, write down this important representation in your notebooks. Now children, pair up and answer. Name the 3 regions of a transistor. Answer. The 3 regions of a transistor are emitter, base and collector. Pair up and answer. Differentiate between NPN and PNP transistors. Answer. Point 1. In NPN transistor, P-type semiconductor is sandwiched between 2 N-type semiconductors, whereas in PNP type, N-type semiconductor is sandwiched between 2 P-type semiconductors. Point number 2. In NPN type, most of the current is constituted by electrons, whereas in PNP type, most of the current is constituted by holes. Now let us understand the action of a transistor. Action of transistor. This is the circuit diagram of NPN transistor used for amplification. The emitter-base junction is forward biased. That is, positive terminal of the battery is connected to the positive terminal of the transistor. The collector-base junction is reverse biased. That is, negative terminal of the transistor is connected to the positive terminal of the battery. The voltage is applied to the base of the transistor. The emitter N layer has a small negative voltage with respect to the base P layer to permit the forward flow of current to the NP junction. The collector N layer has a large positive voltage with respect to the base P layer to prevent the reverse flow of current. Electrons from the emitter are attracted to the collector and a current flows through the circuit. In short, a variable weak voltage called input voltage is applied across a resistor in the emitter base circuit. The output voltage is taken across a resistor in the collect emitter circuit. Small changes in the input voltage results in large changes in output voltage. This is amplification. Block diagram. Children, copy this diagram in your notebook. Application of transistors. Application number 1. Amplifier. Application number 2. Oscillator. And application number 3. Switching circuits. Children, write down these important applications in your notebooks. Note: oscillator is a device for producing electric oscillations of a desired frequency. Children, note down this important point in your notebooks. Think and answer. Why is collector-base junction always reverse biased? Answer. The collector-base junction is always reverse biased to prevent the reverse flow of current from collector to base. Pair up and answer. What are the functions of the three regions of a transistor? Answer. The function of the emitter is to emit electrons or holes into the base. The base controls the flow of charge carriers into the collector. The collector collects charge carriers from the base. In the next capsule, we will study radio communication and television communication.